All right, if you stuck around this long, today we're really going to dive into some really intense concepts, but super important concepts, and we still haven't even touched functions yet, but I promise this is really where the rubber starts to hit the road. So let's just dive into it. I've kind of written a little bit of what we're going to talk about, so let's go ahead and get started. And let's talk about nested for loops. So last video we talked about for loops and while loops, and the video before that we talked about if-else logic, and we learned that you can have multiple layers of if-else logic. So really quick, just to review that, let's say I've got a number which is 10, and what I can do is I can say if the number divided by 2 has a remainder of 0, then I can print even number. All right, and that is, again, the definition of being an even number is that when you are divided by 2, your remainder is 0. You divide cleanly when you're divided by 2. What we can also do is we could say if the number is greater than 50, print large number, and else print small number. So that's nested if-else logic. And notice I printed even number because the first criteria of this if statement was met. So we do all the logic inside, but here's how all the logic inside works. First, I have my print statement, and then I encounter another if-else block, so to speak. So only one of these, actually, it's possible none of them could be executed, but only one of these should be executed. Is the number greater than 50? No, it's not. So do not do this indentation line. So anything else, do this indentation line. All right. And so that's how we got those two. Now, if I change this and I make this 17, all right, well, that's an odd number, so nothing is going to happen, right? So I didn't have a way to catch what happens if the number was not even. All right. And that's kind of where we get into also optional else's as well, just saying that early on. You don't always need an else. Just know that if the other criteria isn't met, then nothing's going to happen. You're not going to indicate that somehow. So maybe you do want to indicate that and you want to print odd number. All right, then you're going to need that else block to be able to catch that. Notice that odd number, you don't get any output of large or small because there's nothing else going on in this logic other than that simple print statement. So we're not going to know whether the number is large or small unless we copy this if-else logic and put it underneath as well. So we could do that. And there we go. All right, but that's what we mean. When we say that there are optional else's, you don't always need one. You don't need elifs either. You don't need else's. You can have an elif, but elifs, remember, have to have a criteria passed to them. So maybe we would say if the number is less than 5, then number is less than 5. Print small number. Well, again, notice that nothing happens here because my number isn't greater than 50 or less than 5. It's in between the two, so there's no condition to catch that. I don't need an else block there. I don't need the elif either. Just know that if it's not greater than 50, you're not going to see anything else happen. All right, so cool. Nested if-else logic, just a quick review on that. So from there, here's what we really need to talk about, nested for loops. So let's make a tuple, and I'll just call it my tuple, but I should probably call it names because I'm going to put Bob, and I'm going to put Alice, and I'm going to put Mike in this tuple. Now, what we learned last time is we could say for name in my tuple, print name. So we've learned that we can iterate through, that's the big word there, every value of your tuple or your list or every character in a string, and you can print them out one by one using this simple print statement. Now, I know we're using print a lot because really there's so much logic and stuff to just get a hold of that we're going to just be printing things out for a while. But let's say we didn't just want to print something out. After we got every individual name, we wanted to do some other stuff with that person, or like we're managing their account once we get the name of the account. So again, as a placeholder to make things simple as we're learning, we could just say for x in range 10, print x. Now what I want you to do is I want you to think, I want you to think about what's going to happen and in what order, and just take a guess in your mind. Now remember that what for x in range 10 is going to do is it's going to start at 0 and then print 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it's going to start at 0 and go all the way up through 9. At some point, we're going to do that more than once. My question is, how are the names and the numbers going to be printed out? Hopefully you have a good guess, and this is how. All right, so what goes on here is once I get into my first for loop, once I get the name Bob, I print Bob, and I'm in that indentation line for this first for loop, right? Then I go to the second for loop in that first indentation line of the first for loop. So here's the second for loop, and for x in range 10, print x. Now I'm inside this line, and once I do this one line, there's nothing else, so I go back and I continue to print this line, go back, continue to print this line. You complete the entire inner for loop before going to the outer for loop and then grabbing the next name and then going through the whole inner for loop. So it's every single outer value is going to have the entire inner loop applied to it. So Bob gets 0 through 9, then Alice gets 0 through 9. And maybe we can illustrate that by even taking the name out here and printing the name, comma, the value, and just seeing them side by side. So that whole time for this for loop, the first time this for loop shows up, we're still in the Bob portion of the first for loop in my nested for loops. So it's a lot of saying loop and for and nested and first and second, but hopefully this printout makes it a little bit more clear what's going on there. So with that being said, let's see what else we can do with this. There are times, and this is where we get into the continue, break, and pass statements, that you might want to break out of criteria early. Like, let's say for some reason, if a name was, or if a value was equal to 4, you wanted to skip over every time it was equal to 4 for some odd reason, all right? Well, we can do that, and here's how we could do that. We could say if x is equal to 4, because that's what we want to skip over, we could simply write continue. And again, remember that you can always have logic after the if statement. So there is where I'll have my print name and x. But I want to show you what happens here. Notice that now in the printout, we never see any name with the value 4 next to it. So what's going on there is this. First, we have Bob, and first x is 0, so we print Bob 0. Then it's still Bob. We're now inside this inner loop. We get 1, so we get Bob 1. We're inside this loop, we get Bob 2. We're inside this list, we get Bob 3. Now x has been incremented up to 4, and so if x is equal to 4 is finally true. That's when it's true, and we get this word continue. And this is what continue essentially says. It says, I will not do anything else under any line of code, whether it's inside of this if statement or whether it's inside of the for loop entirely. What the continue is looking at, the continue is looking at all the code in the for loop's indentation line, and it's saying I will disregard that and just move right back up to the top of the for loop. And that's why we say we continue, because it goes back up to the for loop and continues with the rest of the values that it's iterating through. And if I counter that with, or I see the opposite of that, so to speak, with break, notice what happens now. Now, once I hit 4, I break out of the innermost loop entirely. I break out of the loop that this break is inside of, and there's still an outer loop that will go and continue. I guess continue is a bad word, but the outer loop does not get broken. Only the inner loop gets broken, and the outer loop will, I guess continue is the right word. But again, notice the difference that if I actually write continue, it's just saying, hey, when you encounter 4, don't do any other code underneath here. So I could even put a print statement here. And you'll see that that's useless because it knows that if you hit this continue inside this indentation line, there's no shot of anything underneath it ever being ran. So why is this not kind of what's the word, like shaded a little bit darker in its font, or dimmed, so to speak, it's because this isn't always going to be ignored. It's only ignored when x is equal to 4. Now this is always going to be ignored because it's in the same indentation line as the continue line. So there we go. That's, again, Visual Studio Code kind of being a little helpful to us in giving us clear illustrations. So if x is straight up equal to 4, we know we can break. We know we can skip over that, so to speak, by doing continue. We could also maybe say that if x is divisible by 4, right? Maybe that's what we want to do. Then we want to break out entirely and skip over all those. Now the 4 is missing. Now the 8's missing. And can we do anything else with the break statement? Notice here, oh, that one's interesting. We don't get the zeros printed out. Yeah, whoops, we didn't. I missed that too, because believe it or not, 0 is divisible by 4. Any number is, 0 is divisible by any number, so it didn't show up there. So when I wrote the break statement, actually, that's why nothing got printed, because the first time we get Bob and the first time we get 0, this is actually going to be true, and so we break, and there's nothing to do there. All right, now what else can happen? Let's say we want to break out of the inner loop and the outer loop at the same time. So let's say maybe the first time I encounter 9, I want to break out of this loop entirely, name and everything. I want to get out of both of them. Well, here's what I can't do. I can't put a double break in there, right? Because we know that anything after that break or continue directly underneath is not going to be ran. So that makes you think, oh, okay, then what I need to do is I need to put the break outside of that indentation line or something like that. Well, that won't work either, because I still encounter Bob and Alice. And notice I only ever get to 0. I never get up to 9 because it's breaking out early. And maybe stop, pause, look at this and think why it's never getting to 1, 2, or 3. Make sure you're reading this break statement correctly. It's because regardless of this if statement, this is going to occur. This is happening underneath that indentation line for the for loop. So no matter what if else statement's true or false, this will get ran, and it gets ran the first time we encounter 0. So we only get Bob, Alice, Mike, and then we're out. Okay, so how do we break out of this loop for Bob the first time it hits 9, and we break out for then Alice and Mike as well and don't get to their criteria? Then what we're going to have to do is we're going to have to, before this first break, maybe catch a Boolean and say found 9 is equal to true. Now what I can do is I can even say if found 9, and that actually just is a true or false statement. So if found 9, I can break. And now, there we go. That was the goal. The first time we encounter 9, I essentially want to quit this whole program, so to speak, and not get to any other names. So the first name was Bob. We encountered a 9. So we said, okay, I found 9. That's true. Now break. What's that doing? It's breaking out of this for loop. So now all this code's null and void. Then if I've found 9, which is true, that's how I got out of that first nested for loop, by finding 9, then break. All right, now what I could also do is I could say if found 9 and name equals Alice, and let's see what happens now. Now we're going to get all the way through, all right, the iterations here, and only when I get to Alice 9 does it fully break out, and we skip over Mike entirely. So notice that we never actually get the 9 printed, because if you find 9, we break out of the inner loop. So Bob's never going to get 9, neither is Alice. But once we've found 9 and the name is Alice, we want to break out of the other for loop, the first for loop as well. So it can be a little bit confusing at first as you look at your breaks and continues, but hopefully it gets a little bit easier over time. Now what I want to do is I want to show you where you might actually use this in a more real context, because right now it's just Bob and Alice, and we're just putting names and numbers in there to hopefully make it a little bit easier to just deal with the syntax of what we're doing with the breaks and continues. But what I want to do now is show you kind of an application for this, which would be generating prime numbers. So if you've never seen a prime number, a prime number is a number that is only divisible by itself and 1. All right, and a list of them would be 2, 3, 5, 7, and I'll just stop there, but it goes on forever. So I guess a whole number, so to speak, that is only divisible by itself in 1 are a prime number. And we'll say if a, we'll put it underneath. If a number is not prime, it's composite. Now, again, this is Markdown language, so this isn't Python text. If you tried to type like a sentence like this outside of single quotes or double quotes in Python, you get some kind of crazy red underlining saying, I've got no idea what you're trying to type, because we don't type Python code in regular sentences. But what we're going to do now is we're going to use what we've learned about nested for loops and if else and breaks and continues. We're going to use all of them to generate lists of primes less than some value. Now, what I would encourage you to do is I would encourage you to pause this, honestly, and do some Googling, really. Google generating prime numbers in Python. And depending on your math background, some of it might seem a little crazy, but maybe do some Googling or maybe even give it a shot yourself, because you have, in fact, learned enough about the Python language to be able to generate a list of primes from less than 100 or less than 1,000 or less than 1 million if you want. It might just take a while depending on how much extra math knowledge you have behind the scenes. But really, I want you to pause it, give it a try, think if you can find a way to generate prime numbers, or even just print them out when you encounter them, just like this. But we're going to be a little more sophisticated and generate a list. So hopefully you paused the video. Hopefully you thought about it at least, or maybe wrote some notes down of what you might do. Because that's the real part of being a programmer. It's thinking through and trying things out yourself. Yes, Google's there, but ultimately you want to be a good problem solver, and you're only going to be a good problem solver if you try things first before you see the answer. Okay, so your approach will probably be wildly different than mine, but hey, if you got 2, 3, 5, 7, and 11 and 13 and so on to show up somehow in a print statement and no other numbers, then congratulations, you generated some prime numbers, and I'm really proud of you. But if not, that's totally fine, because this is going to be a little heady and a little complex, but let's see what we can do. So what I'm going to do is I'm going to think about it like this. I'm going to start with a small list of primes that I know. And let's say that I only know that 2 is the first prime number. Then how could I generate the primes less than 100? Well, I guess what I could do is I could check each one of them and see if they're prime. So I could say for a number in range 3 to 100. So what am I saying here? I'm saying, okay, I know 2's prime. What about 3? And what about all the other integers up to 100? Are they prime? So that's what I'm going to do. I'm going to check if they're prime. Well, how do I check if 3 or 4 or 5 or 6 or 7 or 8 or 9 is prime? Well, I need to see if it's only divisible by 1 in itself. Now, another way of saying that, maybe a better and shorter way of saying that, is if any number is divisible by a prime I've already found, then it must not be prime. And maybe that's a light bulb moment for you again, where even just structuring this and saying that statement, that a number is not prime if it's divisible by a prior prime, that might give you the little next piece you need to solve it, so feel free to pause again and try. But otherwise, let's continue. So I've got numbers I want to try, and I've got a list of primes that I know, right? So there's that double nested for loop. What I can do is I can say if my number divided by my prime comes out cleanly, if my prime divides my number cleanly and there's no remainder, then this must be not a prime number. So we can say print not a prime. Now, what's not going to be good about this is that we're just going to see not a prime a lot, and we're not going to see what we're encountering. So this is where we learn about formatted strings. All right. Formatted strings give you a way of using your variable names in a print statement without needing to write it out yourself. And here's how you do it. There's actually multiple ways, but here's the simplest way. You write just an F in front of your string, whether it's single quotes or double quotes. And what that little single F is going to allow you to do is it's going to allow you to inject variable names into your string. And how do you do that? Well, you put some curly braces in there, and notice you get some purple highlighting there. And we can say number is not a prime. And actually here, we're gonna mix this up a little bit just to say it here. We're going to say, we can have more than one parentheses in here, and that's the power of formatted strings. We could say prime divides number, so number is not prime. Now again, prime is the name of my variable inside my for loop. Number is the name of the variable inside my for loop. Let's look at what I'm getting now. And that reads so clearly, and notice we're generating all of that text without needing to type any of that out. It's all happening from my nested for loop. So 2 divides 4, so 4 is not prime. Great. 2 divides 6, so 6 is not a prime. Great. So far we're doing a really good job of catching all the evens, but here's what we're not doing a good job of yet, catching any new primes along the way, right? We still just only have 2 as a prime number, and so we're not figuring out anything else about the primes. So what do? Well, again, we said a prime number is only prime if it wasn't divisible by any prior prime. So what if I get through this entire inner for loop and this if condition is never true? Then if I can get out of this for loop and this if condition was never true, then I must have found a prime number. Now, how can I catch that? Not only can I print out this statement, but maybe I could say if my number is divisible by a prime, I could say composite is true. In other words, if I've found that there's a prime that divides the number I'm currently trying to investigate, like 4 or 7 or 15 or whatever that number is, if it's divisible by any of the primes I've found before, then it's now composite, and I know that. So then once I'm done with this for loop, I can then check to say, okay, if at some point I found that composite was true, at some point in this inner for loop of trying out all the primes I know, and I found it was composite, then I can say if not composite. Now what's going on there? If you're not a composite, think about that logically. If you're not composite, what are you? Well, then you must be prime. So we can print another formatted string. And we could say, we found that number is prime. And if we've found a prime number, we're going to want to append it to our primes list. Whoops, number. I now know that the number I was investigating is prime. Okay, now let's see what goes on here. We're going to make this a little bit smaller and only go up to 10, just for the sake of it. Great, we get an error. And I knew this error was going to happen, but it's a good error. So this error is saying, if not composite, name composite not defined. And you're saying, but how can that be true? Because composite's right here. Well, think about it. The first number we encounter is 3. So is 3 divisible by 2 the only prime I know of? No, it's not. Well, then guess what? None of this logic ever gets ran. And now I'm saying if not composite. And the problem is, if this logic never gets run, then composite never gets defined. So how can we fix that? We can assume that every number we encounter at the beginning is a prime number. Or we can assume that at the beginning of each number's investigation, it's not composite. Right? So we're going to assume any number I'm looking at is prime until I find that it's divisible. Or in other words, I'm going to assume every number I find is not a composite number until I find it's divisible by a prime, and then it is a composite number. So let's see that now. So we found that 3 is a prime. Okay, we found that 2 divides 4, so 4 is not a prime. We found that 5 is a prime. Now notice what's going on here is it says we find that 2 divides 6, so 6 is not prime. We find that 3 divides 6, so 6 is not a prime. We found that 7 is a prime, blah, 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 blah. Let's check out our primes list now. 2, 3, 5, 7. Great, so we found those primes. There's a big problem with our code, though. It's that what's going on right here in these two lines. When you get to the number 6, all right, so maybe what we should do is we should say this. We'll even do this. We'll print investigating number. Oops, gotta make it a formatted string. And you can also inject a new line by pressing \n, and then we can say print formatted string, and we'll just say prime is equal to prime, and we'll put a new line there. So let's see what this looks like now. Whoops. All right, so let's see here. We're investigating 3. The prime is 2. 2 doesn't divide, so we found that 3 is a prime. Investigating 4. The current prime is 2. I'm going to throw out that new line. I don't actually like it in there. Let's run it again. Investigating 3. The prime is 2. Let's put the new line after this or after this. There we go. All right, so sometimes that's just playing around with your code and seeing what looks nice. So, okay, investigating 3. The prime 2, we found that 3 is a prime because 2 doesn't go in. Investigating 4, the prime is 2. 2 divides 4, so it's not a prime. Blah, 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 blah. But here we go. This is the main thing we want to clean up right now. So we're investigating 6. The current prime is 2. 2 divides 6, so we know it's not prime. So in other words, at that point, here's the issue. We shouldn't even check this if we find a composite number. There's no point of going through the rest of the primes if we found that 2 doesn't work. So how can we fix this? Well, we can do this. If the number is a composite, if we get composite is equal to true, then here's what we should do. We should break out of this checking of the primes, and let's see what we get now. In fact, I think I'm going to eliminate those print statements, but hopefully it made it clear just to see for the moment. Let's see what happens now. All right, we found 3 is prime. 2 divides 4, so it's not. 5 is a prime. 2 divides 6, so it's not. And now notice that we're not checking the rest of the primes for 6 because there's no point of doing that. And you would see if we go all the way up to 100 and we didn't have this break in there. All right. Now we're wasting a lot of time. Look at 12. 2 divides it. 3 divides it. And we're just needlessly checking essentially a bunch of numbers that we already know. 10 gets multiple checks when we don't need to check it more than once. Once it's divisible by 2, there's no use of checking any other primes. It's no longer prime. So that break statement comes in handy with really speeding up our code. All right. Now, did we cover everything we need to? We might have. Let's check our primes list now. 2, 5, 7, 11, 13. There we go. We got all the primes up to 100. You can even go up to 1,000 and rerun this. And I think it's already done. It is. So we found a pretty quick way of generating primes just by checking if it's divisible by a previous prime. Now, I am actually a math major. There's way faster ways of doing this, but this is a pretty good introductory way of easing your way into coding. And this is really, think about this. Way back when people actually cared. People care about prime numbers still, but when they were really discovering prime and composite numbers, think about how useful this would have been back then, because some of them had to try, for instance, 5,337 and just see if it's a prime number by checking and checking and checking and checking all the prior primes they found themselves. And we've got code that can do that now in literally microseconds, especially if we throw away the print statement here and throw away the print statement here. This is happening incredibly quick. And what do? Less than 10 lines of code. And we can now, as long as we're okay to let our computer run, we can find as many prime numbers as we want. All right. All the primes under 1 million. Let's see how long it will take it to run. I know this video is getting a little long. That one actually might take a little while before we optimize it. So, hey, maybe we'll optimize that in another video. It won't be our next one. We've still got so many more basic Python concepts to learn. Oh man, you know what? We didn't get to the continue, break, and pass, and while loops. So we'll do that in the next video, but I think that's enough for now. We've really covered a lot of ground here, and all of that, again, it's a lot of learning just to get these 10 lines of code, but that's kind of the magic, is there is going to be a lot of learning on the back end, but once you realize what this program does and you realize how short it actually is, if you know how to structure it and you know what tools are available, like being able to break, having nested for loops, you can accomplish some pretty big tasks with very few lines of code. So what do we need to do in a future video? We need to cover while loops. We need to cover how to do this faster so that it doesn't take 33 seconds to get the primes less than 1,000,000. Trust me, there's a way to do it. And I guess we'll see that on other videos. Thanks for sticking around, and I hope to see you in